Hello, students. I am going to pick up where I left off in the last video that, to the best of my knowledge, only one person has watched. If you recall, what we did last time is we got a data file from Darwin's Demons and we put it in a directory, and then we told R, hey, go look at this directory and then make this graph. And so we run that. Now it knows where to look. You can kind of ignore this. We're going to load our ggplot2 library, and then to make a simple graph with dominance, we're going to have it throw an error. Oh, that's right. I have to re-import my data. My environment is empty, so the other thing is we noticed that some people can't do this, but I can point to my data and in it goes. So now my data are in there. Sorry about that. And then we can make a simple graph. And I chose this trait dominance for reasons that you'll see later. And you can see this graph isn't particularly exciting, and nor have we done any kind of an experiment, but bear with me because we kind of got to get to the point where you're framing an interesting hypothesis, and I want to walk you through the connection between observation and hypothesis here. As in your fruit flies, I mean, your hypotheses are driven largely by things you learn in lecture, like, oh, I learned about sex-linked inheritance. I wonder if white eyes are sex-linked. That's my hypothesis, you know. But in the video game, we're not quite there yet. So there's this dominance trait, and just to remind you, dominance is a value that we use in the game to determine the order in which the aliens enter the field of play. Highest value goes first. Highest value dominance is the front of the line. Probably should have called it entry priority or something like that, but anyway. And let's make an observation here. I played that game for 18 generations, and our observation is that if every data point is an alien here, as generations increase, it seems like dominance is trending downwards. So we made an observation. Dominance is going down. It's a pattern that we have observed from this simulation. And a hypothesis is typically, if it's a good one, a hypothesis is about the underlying process that might be creating that pattern. And in our case, I mean, there's lots of different things. Maybe it's just like, you know, that's how we coded the game. Who knows? But in our case, we're interested in hypotheses related to biological processes like evolution by natural selection. And so we could say, I have observed this pattern, dominance goes down. My hypothesis is dominance is going down because it is under selection. Individuals with lower dominance values have a selective advantage, and therefore they have more offspring. Okay? So we're going to start working towards testing that simple hypothesis. And if you go look at your hypothesis testing in Darwin's Demons folder, I'll navigate to that here. There won't be a folder on your machine. It'll be in BB Learn. Maybe I should have gone to BB Learn. Anyway, we'll edit this out in post. Look at all of the things. Hypothesis testing using Darwin's Demons. Everybody should have this little document, and presumably you've read it, but if you're like the average undergraduate student, you don't read syllabi and things like that. We talk about the idea of using simulations and stuff like that, and you know, I don't know if anybody's been to our website to kind of see the kinds of things that we're working on, but look at this. Some hypotheses that could be tested in Darwin's Demons. Number one, a particular trait is under selection for 200 points per trait. So, I mean, there's other ones that we'll go through, but a particular trait is under selection, and we've just observed a pattern that makes that hypothesis non-trivial. is dominance under selection? My hypothesis is dominance is under selection. This graph, however, is insufficient evidence. It's consistent with that hypothesis, we think, but by no means is sufficient to prove it with any degree of evidence. So let's build towards that. Is dominance under selection? That's our hypothesis. So let's think about this. If dominance is under selection, if that is true, what do we predict? Okay, we predict that it would change over time, probably in a repeatable way. But what we really need right now is a control condition. We need to be able to compare this to something when we know dominance wouldn't be under selection, right? So that's what we're gonna set up, and so we're going to go to Darwin's Demons, and we'll talk a little bit about the experiment that we could run that shows that dominance is, or that tests whether dominance is under selection. So I'm gonna get out of our studio now, and we'll go to Darwin's Demons, and we will set that experiment up. So here's Darwin's Demons. Yay, fun. Recall, again, we're about to start collecting experimental data. Make sure record data is selected, okay? I mean, it's a real bummer to play this game a lot and then you don't have your data, okay? I said okay, and that verbal crutch is driving me nuts. Recall that what we want to do is go to experiment mode and then hit start. And at this point, we're going to run an experiment where we're testing the hypothesis that dominance, the trait dominance, is under selection. And so now we really want to be careful about recording the parameters under which we run our replicates, because we have to play the game more than once to really test our hypothesis. So I'm going to go ahead and leave all of the default parameters set the way they are, except remember, when you're running these experiments, turn anomaly rate to 0. It's just going to make it easier because you're not going to get selection swamped out by weird boss creatures migrating in. Now the other thing is, give yourself 100 lives or 1,000 lives. Just make sure it's always the same, because that's kind of fun to plot out. And then what we want to pay attention to for this very simple experiment is these fitness components. So by default in experiment mode, all 3 fitness components are turned on. That's fine. And if you recall the last time when we collected the data, I turned lifetime off and I left aggression and accuracy on. This time though, I am going to tell you about your control conditions. The cool part about Darwin's Demons is we can turn all of the fitness components off. And if you do that, it's just, the reproductive model is just random mating. You randomly select a mom and a dad, they have a baby, and you keep doing that until you make the population size of the next generation. So when you turn all of the fitness components off, it becomes a really nice control condition for testing whether a certain trait is under selection or not. So what we'll do is we'll run several replicates in which the fitness components are turned off, and we'll run several replicates in which one or both of these fitness components are turned on. And then when we compare the results, our hypothesis predicts that when components are turned on, when selection is turned on, dominance will change in a predictable way, and when it's turned off, it should stay flat. That's the prediction of what our data will look like when our hypothesis is true. So I am going to quickly play a control condition and collect some data here, and then in the next video we'll jump back to R. Okay, so I'm going to quickly play the game under specific conditions. But what I want you to do is, I don't care, you can screenshot it so you know what parameters you used, or better yet, old school. I got my notepad here, and I'm actually collecting data now. I'm running an experiment, and so we need to record. I need to be able to repeat what you are doing, and you need to say in the method section what you did. And so I'm going to write down all the parameter values for mutation rate, standard deviation, anomaly rate, all of those kinds of things. I'm writing down all the parameter values. Okay. Write down lives 100, anything that you think you need to write down so that I could exactly repeat what you did. So I'm going to give my, actually, 100 lives, not 1,000. Then I hit confirm. The next thing I have to record is, for this simple experiment, what ship and other equipment I'm using. So in this case, I'm going to go back to one of my favorites, the manta ray. And we used homing missiles in the last time, and then we used an ice sword the last time, and I used that. Okay, and so I'm writing those down, manta ray. Some of these things are recorded in the data file and others are not, right? But I want to write these down because you're going to want to report that in your methods section. So once that's ready to go, now the hard part, you have to play a game for 18 generations. Now let's talk a little bit about how long to play the game for a particular replicate. I'll show you in the data why I'm telling you this, but if you play for 10 generations, you may or may not get significant results. Less than 10 generations, you probably won't get significant results. I recommend you play for at least 15 generations when you're collecting data. Here. This is with all of the fitness functions off. Okay, so we finished generation 18, which is what we did in the last replicate. So I don't know if you guys noticed any difference, but I'm going to hit main menu and then we'll jump back to R and finish this little video. So exit out of Darwin's Demons. Here we are back in our studio. Okay, and remember, our hypothesis is that dominance is under selection. And so now we have one replicate where we had fitness functions turned on, and we just completed another one where fitness functions were turned off. And I think what I'm going to do is I'll show you just quickly. So now, actually, darn. I got to go back and get the new data file, which we did on 9, 10, 15, 12. And I'm going to copy that, and I will go back to the directory. And so now I've got 2 data files in our working directory. And I can go and import the other one, just like we did the first one. So now we've got 2 data files. And now we want to be able to compare the patterns in the 2 data files. And so I'm going to do it the ridiculously dumb way, and then in the next video I'll show you how to do this in a smarter way. So here we said, hey, ggplot in using our old data file this thing. And now what I can do is I can say, well, let's just change that, and we'll look at it for the new data file. And it auto completes for me. And if I go ahead and I do this, okay, so no selection, selection. But visualizing things in this way is super clumsy and is riddled with flaws. And so in the next video, I'm going to show you how to harmonize your visualization from different replicates. All right.